let's move on and see that how we create arrays. There are multiple ways of creating the array, but one of the most popular way is to use np.array. np is numpy, and numpy library has a function or method array, and you can pass list or any iterable for that matter into that. Most of the time you'll see in literature or in examples also that Python list is provided. So what I'm doing, np array is my method or function. I'm providing it to a list. This is my list 14253, and when I'm providing this into np array, what I get in result, an array. I can assign this array some I can declare it with some variable also like x, right? And in that case, if I call x after that, let me call x. X is an array. What is the type of array? What is the type of x? X is nd array. This is how you create. This is the most popular way of creating arrays through a Python list. But effectively, you can create in multiple ways, and we are just going to see that. So np array is this. What is the data type of this array, right? Now, friends, remember, just now I told you that in NumPy arrays has to be homogeneous, right? So all the elements has to be homogenized, right, of one data type, okay? Here it was, if you notice in this particular case, right, what is happening? These three elements are integers, but this one is float. And what did we tell? That everything has to be homogenized. It has to be one data type. What NumPy will do if it encounters this thing? It will upcast to the minimum supported data type. What is the minimum supported data type? Float over here. Integer and then float, right? So it will upcast every integer into float, right? So you see the dot which is coming after that. It is because of that, right? Because 3.14 is present over here. Similarly, you can call the d-type attribute of NumPy array, right? D-type attribute, and it will show you float 64. So float 64 is the data type for this particular array, right? Similarly, if I give this type of list, my list can be heterogeneous. So if I give this type of list to my NumPy np.array, what it will do? It has to upcast this not to the float, but to a higher degree, which is a string. So the data type is U32 over here. And you notice everything has been upcasted to a string. And that's why the quote is also coming over here. The quote is coming, right? And you can fetch the data type also, which is U32, right? Okay. Now, another thing, you must be noticing that what is this dot operator and d type, right? Whenever we are doing. So let me assign this thing to x, okay? Not this thing, this thing. Let me assign it to a variable x, okay? Now, let me just print x over here. X is an array of these and the data type is U32, no problem. Now, every Python object has a dir method, right? And what dir method actually shows you is attribute and methods. Methods are nothing but functions which are associated with that particular class. Attributes are the values which are the characteristic of that particular object. So X is an object of which class or which type? X is an object of NumPy array, NP array class, right? Now, what are the functions, methods, and attributes which are associated with that? If you have to see, you have to run a dir command on this. When you run dir, and this is just a side note, right? This is not important to NumPy, but this is valid for all Python. When you run dir, you first initially see double underscore. That means these are internal methods or attributes, right? Which we do not should access. Actually, we can access that also. Probably later I will show you. But most important thing is, if you come down, you'll see the normal, these type of things, right? Now, few of these will be attributes of that class and few will be methods of that class. The difference only is the attribute is a characteristic, right? Characteristic that it will be a number or some character or something. It has a value. Functions or methods are like functions, and you have to call that with two curly braces, right? So just remember, it has attributes and it has methods also. Now let me see something which I can show you as an example, right? Now d type you are seeing, right? So x dot d type. x.dtype is an attribute. I didn't put two curly braces over here, right? If I put two curly braces, it will throw an exception that is not callable, right? But on the other hand, if you see, let me show something like maybe argmax or something. Maybe it's a method argmax. Okay, see, when I called it with argmax, I supplied two curly braces notifying that this is a callable function or method. And what is argmax? Argmax is the argument maximum. That means it is saying to me that which is the maximum number over here, or maximum argument, right? So maximum was, I think it was taking it as 4. I don't know why it is taking it as 4. Maybe it is converting to a number and then taking it argmax. Let's see that what argmax calls. Okay, a.argmax. Return indices of the maximum value along the given axis. So what it is returning? It is returning the index of the maximum value 0, 1, 2, 3, 4. So in this particular string, ML with AP is coming as the maximum value of the string, right? So maximum value. Let's see it with a more clear example of, let's see, our initial. Let me initialize this and then call it. Now call me x argmax 3. Why it is coming 3? My x is, if you see, let me just put that. What is my x? My x is 14253. 3 returns the index. What is the index 3? 0, 1, 2, 3. So it returns, argmax returns the index of the maximum element, right? Who has the highest number or something, right? Maximum number. So maximum is 5. The index associated with that 3, that's why it is returning. But the point I'm trying to make is that whenever you are calling a method with a dot operator, you have to apply these two braces. If you are calling an attribute like dtype, you do not have to do that. If I remove this, it will not give me. It is saying that, okay, argmax is a function. That's all it is telling, but it is not giving me the value. And how you know that is the dir, through the dir method. So this is very important, and this is not just for array, but it is useful throughout Python, right? Okay, moving on. Okay, now you can also define the data type, right? When you are initializing the array, you can define the data type. So it accepts a data type argument, right? If you see np.array and help of that, right? If you see somewhere over here, yeah, dtype, you can pass an argument dtype. And when you pass an argument dtype, the desired data type for the array, if not given, then the type will be determined as the minimum type required to hold the object, minimum type. That's why if you do not specify this, right, and the last element is 4.o, what will become? Everything upcasted. Minimum data type to support. What is the minimum data type to support? Float, not integer here. That's why everything upgraded to or upcasted to float. Okay. Arrays, as I was saying, it's an n-dimensional array, right? So one-dimensional is a vector, two-dimensional is a matrices. More than two-dimensional are called tensors usually, right? So it can support the similar operation, whatever we have talked, it can support in 2 dimension also, and we can create it like this. Okay, let me just say, what is this x dot? Where is the dot coming? Okay, yeah, there is no operator over here, so let me remove this. Okay, dir x we have already seen, x shape. Okay, type of x. Now what will be the shape of x? X is this. What will be the shape? It's a 2-dimensional array, 3 cross 3. How many dimensions? 2 dimensions, right? And do we have a dimension? It will, if you see, come to D, come to diagonal dot D type, ndim or something would be there, and klmn, ndim, right? This is also an attribute, right? So if you see, instead of shape is also an attribute. If you see ndim, what is it saying? 2. That means how many dimensions it has? It has 2 dimensions, right? It's a 2-dimensional matrix, right? 2-dimensional. Type of x, ND array. Everything is an ND array object, right? Okay. You can do the same thing with a multi-dimensional array. You can create the multi-dimensional array like these type of list constructor you can pass, or you can just statically pass the parameter. Any iterator, basically, if you pass through that, it will construct an array. Okay. Creating now that was the through creating through list. Now you can create from the scratch also. How do you create it from scratch? Numpy has the methods like zeros. What is zero? That it will initialize everything to 0. What is the first argument? 10. That means I need 10 elements, everything initialized to 0, and the data type should be integer, not float, integer. So it will be 0, not 0 dot. Okay. Similarly, NP1s, you can specify 3 cross 5 cross 8. So it's a 3-dimensional. In the tuple, this tuple, you have to pass the shape of the object which you are trying to create, or shape of the ND array which you are trying to create, and then the data type, right? And NP1s represent that everything should be initialized to 1. That's why 1 dot, because it's a float. What will be the shape? 3 cross 5 cross 8. How do you read this? You read this from right to left. So you first start with 5, 8. This particular thing is a 5 cross 8. You see, there are 5 rows and 8 columns. And this is into 3. That means this is repeated 3 times. This is the way you should read the multi-dimensional array. Now you can create a multi-dimensional like this also. It's a 4-dimensional array. We can't visualize this, but it's a 4-dimensional array, believe it or not. Okay. Similarly, n full, when you pass the full, you pass the tuple, which is the shape of the array, and then you pass what it needs to be initialized to, right? Simple. Similarly, like Python range is there. In NumPy, we have a range. What is that a range? A start. First parameter start. Second parameter stop. A stop is exclusive. Like you don't reach that, you stop before that. And this is the step size. What is the step size? 2. That means it skip every other element. So what will be constructed? 0, 2, 4, 6, 18. 20 is not included because this is exclusive of that. This is inclusive. A start is inclusive. A stop is exclusive, right? So this is similar to what, if you have seen Python list, this is very similar to that. Okay. Similarly, like linspace also, a start, a stop, and divide into 5 parts, right? So 0, 0.25, 0.751, like 5 elements, right? Again, through NumPy also provides random normal. What is a Gaussian normal distribution, right? 0 to 1, that means as mean as 0, standard deviation as 1. So you can always initialize it, and these things are particularly useful when you are initializing deep learning models, right? At that time, usually you start with the standard Gaussian, a standard normal distribution, right? So you can, and this again you pass the tuple. When you pass the tuple 3 cross 3, that means I need a 3 cross 3 matrix or a 3 cross 3 ND array. My values should be a normal distribution between 0 and 1, right? With 0 and 1, okay. Rand int, this is normal distribution, this is rand, that means 0 to 10, specify the value. So it will pick a random value between 0 to 10 and populate a 3 cross 3, simple. Identity matrix. What is identity matrix? It's a square matrix where the principal diagonal as 1 and rest all the elements as 0. Principal diagonal 1, rest all the elements 0. Why we are specifying only 1? Over here we are specifying 3 cross 3. Why not we are writing 3 cross 3 over here? Can you answer that? Because our identity matrix will always be squared, right? There is no point in specifying 3 cross 3. You can't make identity matrix as 3 cross 4 because the principal diagonal all has to be 1, right? You can create empty also, np.empty. So it will create the shape, but it will not initialize with anything. And when you try to print it, whatever garbage is there in the memory at those locations which it has assigned, it will be populated. So some garbage is coming over here. Okay. NumPy standard data types. So we have seen the data types as integer, float, but this is the complete list of all the data types which NumPy supports, right? NumPy supports in its n-dimensional array. So n-dimensional array elements can be one of these data types, but it has to be homogeneous. One array can only contain one type of, all the elements has to be of one type. That's it, right? But it can contain, those elements can be of these data types, right? That's what it means. With that being said, I think we have come to the end of our introduction. Next time we'll go deeper into what is n-dimensional array or ND array. Okay. With that being said, thank you. Bye.